Write the sum of the series 2 plus 4 plus 6 plus 8 plus and so on up to 2n. So we can take 2 common and we can add 1 plus 2 plus 3 plus 4 plus and so on up to n. So 2 times sum of first n natural numbers. We know sum of first n natural numbers is n into n plus 1 upon 2. So we can write n into n plus 1 upon 2. So we can cancel here 2 and we can say n into n plus 1. Or you can just remember the sum of first n even natural numbers is equal to n into n plus 1. Okay. Write the sum of the series 1 square minus 2 square plus 3 square minus 4 square plus 5 square minus 6 square plus and so on 2n minus 1 whole square minus 2n whole square. Let us write the sum as Sn is equal to 1 square minus 2 square plus 3 square minus 4 square plus 5 square minus 6 square and so on 2n minus 1 whole square minus 2n whole square. By taking minus common, we can write 2 square minus 1 square plus 4 square minus 3 square plus 6 square minus 5 square plus and so on. We can write 2n whole square minus 2n minus 1 whole square. So let us keep the brackets in pairwise. So each pair is in the form of a square minus b square. So we have a square minus b square is a minus b into a plus b. So we can write which is equal to minus of 2 square minus 1 square, we can write 2 minus 1 into 2 plus 1, and 4 square minus 3 square we can write 4 minus 3 into 4 plus 3, and 6 square minus 5 square we can write 6 minus 5 into 6 plus 5. And so on up to 2n minus of 2n minus 1 into 2n plus of 2n minus 1. So you can write minus of 2 minus 1, it's a 1 into 2 plus 1, it's a 3, and here 4 minus 3 is 1, and we know the difference of two consecutive numbers is 1, so we can write 4 plus 3 is 7, and 6 minus 5 is 1 into 6 plus 5 11, and so on up to 2n minus 2n plus 1 into again here 2n plus 2n minus 1. So we can write here minus of 3 plus 7 plus 11 plus and so on, it's 1 into 2n plus 2n, that is 4n minus 1. So clearly it is a arithmetic progression, it's a series of AP whose first term a is equal to 3 and the common difference d is equal to 7 minus 3, that is 4, and the last term is equal to 4n minus 1, and we can write the sum of n terms is, sum to n terms is nothing but n upon 2 into first term plus last term a plus l. So we can write minus of n by 2 times of a plus, that is first term is 3 and the last term is 4n minus 1, which is equal to minus n upon 2 into 4n, 3 minus 1, it is 2, or we can take 2 common, 2n plus 1, so which is equal to minus n times of 2n plus 1 is the answer. Write the sum to n terms of a series whose rth term is given r plus 2 power r. Rth term is given r plus 2 to the power r. So we need to find the sum to n terms. Sum to n terms will be taken as summation of ar, where r is equal to 1 to n. So we can write summation of ar, that is r plus 2 to the power r. We can write summation r plus summation 2 to the power r. Summation r, that is r is equal to 1 to n. It's a sum of first n natural numbers, that is 1 plus 2 plus and so on to n. And summation 2 power r, we can write 2 power 1 plus 2 power 2 plus 2 power 3 and so on up to 2 to the power n, where r is equal to 1 to n. So the first one, sum of first n natural numbers, we can use the formula n into n plus 1 by 2. And the second series, which is in the form of GP, where first term is 2 and the common ratio is 2 square by 2, that is 2. So in sum to n terms formula, we have a into r power n minus 1 upon r minus 1. So here we can write a is equal to 2 into r, that is 2 to the power n minus 1 upon 2 minus 1, which is equal to n into n plus 1 upon 2 plus 2 into 2 power n minus 2 into 1 2 upon 2 minus 1 is 1. So we can write n into n plus 1 upon 2 plus 2 power n plus 1 minus 2. So this is the sum. If summation r is equal to 1 to n, r is equal to 55, and summation r is equal to 1 to n, r power 3, we have to find. Summation r is equal to 1 to n, r is equal to 55, that is sum of first n natural numbers, that is 1 plus 2 plus 3 plus and so on n is equal to 55, that is n into n plus 1 by 2. We know sum of first n natural numbers is n into n plus 1 by 2 is equal to 55. Let us consider this in equation 1. And now to find summation r is equal to 1 to n r power 3, which is equal to 1 cube plus 2 cube plus 3 cube plus and so on n cube, sum of cubes of n natural numbers. We have that n into n plus 1 by 2 whole square. Sum of cubes of n natural numbers formula is n into n plus 1 by 2 whole square, that is we can write 55 whole square. So from 1 we can say 55 whole square. 55 square is 3025. So 3025 is the answer. If the sum of first n even natural numbers is equal to k times the sum of first n odd natural numbers, then write the value of k. Given that sum of first n even natural numbers is equal to k times sum of first n odd natural numbers. So we know that sum of first n even natural numbers is n into n plus 1 is equal to k times of sum of first n odd natural numbers is n square. So we can write k is equal to n into n plus 1 upon n square, or we can write n into n plus 1 upon n square. We can write n into n, so we can cancel one n and hence we can write k is equal to n plus 1 upon n, or we can write k is equal to 1 plus 1 upon n. Okay. Write the sum of 20 terms of the series 1 plus 1 by 2 of 1 plus 2 plus 1 by 3 of 1 plus 2 plus 3 and so on. Here the first term is 1, second term is 1 by 2 of 1 plus 2 and third term is 1 by 3 of 1 plus 2 plus 3. Similarly, its nth term we can say an is equal to 1 by n of 1 plus 2 plus 3 plus and so on up to n. So which is equal to 1 upon n into sum of first n natural numbers n into n plus 1 upon 2. So which is equal to n plus 1 by 2. So its nth term is given n plus 1 by 2, n plus 1 by 2, and then summation, or we can consider AR is equal to, or we can write AR is equal to R plus 1 upon 2 summation over R is equal to 1 to 20 AR, which is equal to summation of R is equal to 1 to 20 R plus 1 upon 2, since we required the sum of 20 terms. So which is equal to 1 upon 2 is common, we can take outside, and summation of R plus summation of 1 upon 2 summation of R, that is R is equal to 1 to 20 is sum of 20 natural numbers. So we can write 20 into 20 plus 1 upon 2, and summation of 1 is R is 1 is added 20 times, so we can say here 20. So on simplifying, since R is equal to 1 to 20, so 1 is added 20 times, so it is 20. So 1 by 2 into, so here 2 10 times, so 10 into 21 plus again 1 by 2 into 20. So here we can say 5 times, and 21 5s are 25 is 105, and here 2 10 times, so we can write here 10. So 105 plus 10 is 115. So the sum of first 20 terms, we can say that 115 is the answer. Write the 50th term of the series 2 plus 3 plus 6 plus 11 plus 18 and so on. So in the given series, the first term a1 is equal to 2, the second term is 3, and third term is 6, and fourth term is given 11, and fifth term is 18. So we can write 3 as 2 plus 1, and we can write third term as 2 plus 4, that is 2 square, and here we can write 2 plus 9, that is 3 square, and here we can write 2 plus 16, that is 4 square. So here we can write this is 2 plus 1 square, and here we can write 2 plus 0 square. In this pattern, we can say that its nth term is equal to 2 plus fifth term is 4 square, you are getting, fourth term is 3 square, so nth term is n minus 1 whole square. So we can consider the nth term, a general term for the given series is an is equal to 2 plus n minus 1 whole square, and hence we can say 50th term we can write 2 plus 50 minus 1 whole square, that is 2 plus 50 minus 1 is 49 square. So 49 square plus 2 is the answer. Let capital SN denote the sum of the cubes of first n natural numbers, and small sn denote the sum of first n natural numbers. Then write the value of summation r is equal to 1 to n capital SR by small sr. So given capital SN is equal to sum of cubes of first n natural numbers, that is 1 cube plus 2 cube and so on, n cube is equal to n square into n plus 1 whole square upon 4. This is sum of cubes of first n natural numbers, and small n Sn is equal to sum of first n natural numbers, that is n into n plus 1 by 2. So from this we can write sum of first r natural numbers. We can write 1 cube plus 2 cube and so on up to r cube is equal to r square into r plus 1 whole square upon 4, and sum of first r natural numbers, which is equal to r into r plus 1 by 2. So from this we can divide SR upon small sr is equal to r square into r plus 1 whole square upon 4 divided by r into r plus 1 by 2, or we can write here r square into r plus 1 whole square upon r into r plus 1 into, so we can write here 2 upon 4. So we can cancel here r and r plus 1, r plus 1. So here 2 times, so it is nothing but r into r plus 1 upon 2. And let us consider the summation. Summation over r is equal to 1 to n. Capital SR upon small sr is equal to summation over r is equal to 1 to n r into r plus 1 upon 2. So 1 upon 2 constant we can bring outside, and summation over r into r square plus r into 1 r, or we can write 1 by 2 times summation over r square plus summation over r. So 1 by 2 times of summation of first square, sum of the squares of n natural numbers is n into n plus 1 into 2n plus 1 upon 6, and summation r is nothing but sum of first n natural numbers, that is n into n plus 1 by 2. So we can write here 1 upon 2 times of n into n plus 1 into 2n plus 1 plus 3 times of n into n plus 1 upon 6. So which is equal to 1 upon 2 times of, taking n into n plus 1 common, and we have 2n plus 1 plus 3 upon 6. We can add 1 upon 12 times of n into n plus 1 into 2n plus 3 plus 1 is 4, or we can take 2 common here, 2 times of n into n plus 1 into n plus 2, so 2 6 times, so we can add n into n plus 1 into n plus 2 upon 6 is the required sum.